Okay, question 16. But before we start question 16, I need to go back to question 15. I forgot to talk about question 15. The very last part, the E part, that is the limit. So limit as x approaches to negative infinity, what it means is that if x goes to the left, okay, if x goes to the left, where will the function go? If x goes to the left, the function goes down. So we say it is equal to negative infinity. All right. Limit as x goes to positive infinity, which means that if x goes to the right, on the function, where does it go to? It goes to also negative infinity. So it's very easy. Okay, just making sure you know you look at the graph, you make the proper interpretation. All right, question number 16. All right, we have a really long question right here. It says you have a function right here, 6x cubed minus x squared minus 5x minus 2. And you have to list all the possible rational zeros. You have to use Descartes' rule of signs to develop a PNI chart. Synthetic division to find the zero, not fund the zero. To find the zero. Write the function in factored form, sketch the function. So it seems like you can factor this one out. Okay. Now let's go ahead and do part A. Part A sets list the possible rational zeros. Possible rational zeros. Now, possible rational zeros are the factors of the constant, which is 2 and 1, over the factors of the leading coefficient, which is 6, 3, 2, and 1. It includes positive and negative. So you want to make a list out of this. So you have 2, you have 1, and then you have some fractions. You have 1/6, you have 1/3, you have 1/2. They're all positive and negative. Okay, so 2/6 is 1/3, which we have it already. We also have a plus or minus 2/3. Okay, and I think that should cover all the possible values. Now, how do we know which one of these could be a zero? Now, in class, as I said in class, I would say use your eyeball. Okay, just think about and think something easy first. Don't think about the fractions. Fractions are too crazy to consider. So pick a simple number. Pick 1. Okay, so you think about what if x equals to 1? What would it be? So if you can eyeball it, okay, I'm showing you the work, but if you can eyeball it, you find out that, oh, wait, hold on, you have 7 minus 7, which gives you 0. And if it's 0, that means you have a point, 1 comma 0. That means x minus 1 is a factor. So x minus 1 is a factor because f of 1 is equal to 0. We have a solid proof. Okay. Now, let me go ahead and also do the PNI chart as well. I got too excited about the zeros. For the PNI chart, I have to find out the f of negative x. So the sign would change if the power is odd. The sign would remain the same if the power is even, because negative times negative is still positive. So no sign changes for those cases. All right, so we have f of x and f of negative x. So p, n, and I. So we count the sign changes. Then we use a different color. So for positive x, there's only one sign change. For negative x, we have 1, and we have 2 sign changes. And because x is having a power of 3, that means the total possible number of roots will be 3. And that means we will not have any imaginary roots. We cannot and will not have any imaginary roots. All right, now that's the one row. Okay, one row of PNI chart. Is there any other option? And we say yes, we have another option because there's a 2 for the negative. That means we can subtract the 2 and move the 2 to the imaginary. Okay, so you only subtract 2 when you have a number under the positive or negative that's 2 or greater. And whenever it's 2 or greater, you would consider a situation where 2 of the roots will go to the imaginary column. So we have these 2 situations. So we know that there will be a positive root, possible root, but we don't know if there's a negative root or not. So, and we were very excited. We found out the positive root, which is 1. So we can go ahead and do our synthetic division to find out the other, or what is the quadratic expression. So we have 1, we have 6, 1, -5, and -2. So bring down to 6. 6 times 1 is 6, and then we have 7. 7 times 1 is 7, and then you have 2. 2 times 1 is 2, and then you have 0 for the remainder, which makes sense. Okay, so that means f of x could be expressed by x minus 1 times 6x squared plus 7x plus 2. So now the question is, can we factor this one, or would it give us imaginary? Okay, would it give us imaginary? Now, how can we quickly find out? What's a quadratic? So back in algebra 1 or algebra 2, you learned something to find out if it would give you imaginary. That's called the discriminant. And this is a good time to use discriminant to spot this one out, because the A value and C value, they are both positive, which means that the subtraction of the discriminant remains. So we say, well, 7 squared minus 4 times 6 times 2. So 7 squared, it's 49. And then 4 times 2 is 28. 28 times 2 is 56. But no, hold on. Sorry, my bad. 46, 26 times 4 is 24. So 48. Oh, that's actually equal to 1. So actually, it is not imaginary, because you actually have a number, and if it's a 1, then it should be something pretty nice. So let me see if I can factor this one out. What we know for sure is that it must be 1 and 2. And how can we get 7x in the middle? 3x. Nope. Wait, hold on. Oh, the other way. 2x plus 1, and then 3x plus 2. So now you have the other roots, okay? You have the other 2 negative roots. The other 2 negative roots are -1/2 and -2/3. So you can plot those points. You would say -1/2 right here, -2/3 right here, and then you have a x plus 1 right there. I mean the positive one for the root. It's a cubic function. It starts low, goes back down, goes back up, and it's asking for y-intercept. It's not, well, y-intercept, it's -2. It's given from the function. So we have this graph right here. As x goes to -infinity, f of x goes to all the way down, so -infinity. And as x goes to infinity, f of x goes up. So that's infinity. Okay, so we have a factor form right here. We found out the zeros. So that's how we have the using PNI chart, the card through of sign, possible rational zeros to get us out and draw